All righty then. Good evening, everybody. Welcome at YouTube, Facebook, and Rumble. And welcome to the rabbit hole. Now we'll do it as a rabbit. Here we go. Ding, 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 ding. There we go. Over here on Twitch. Yeah. Let's see. I was sharing that screen, so hide that one. Show on screen. There he is. That's my boy up there. So he's got it. Oh, he's unmuted now.
How's it going?
Good, man. Good.
Oh,
I just took a B12, so hopefully I'll wake up a little bit. But struggling.
You're doing better.
Yeah.
well, I had my Kit Kat, so I should be sugared up for a while.
Oh,
You know, it's not the up that I have problem with. It's the coming down. It comes down fast. Poosh. But let's see. Screen, window, this one. There we go. And loading share screen. All righty. Here we go. It's the morning report. All right. Hang in, everybody. Yeah.
Hi, I'm Joe of the Joe Slick Live Show. My interactive live show is on twitch.tv/Joe Slick Live. Monday through Friday, 7 to 9 a.m. Mountain Standard Time, and occasionally in the evenings at 7. During the live show, I review and talk about reports from government, private, and other reporting agencies and websites regarding celestial and terrestrial phenomena. Topics will include solar flares, sunspots, geomatic storms, and near-Earth asteroids and comets that are being monitored around the world. Included in the report is current events in the last 12 to 24 hours here on Earth, consisting of volcanic, seismic, and weather events. I close the morning report off with what's happening in the local and world news. Thank you, and you can be a part of the morning report by going to twitch.tv/Joe Slick Live. Look forward to seeing you there, and remember, don't get none on you.
And don't forget to like and subscribe, share, and hit the bell button over there on YouTube so when you get notified we're alive like we are right now. All right.
doing it live.
Doing it live, man. Doing it live. There we go. Good evening, everybody. And I didn't put the, anyway. First of all, I want to thank one of our sponsors right there, The Shit Show with Luke Clemmer, who happens to be out there right now, better known as the Walleye King. And I don't know if he's a Walleye King this year, but he's been trying to kill him.
Been trying anyways.
He has a show here on twitch.tv/the_walleye_king. And he's on at Friday nights at 10 p.m. Central Standard Time. If you don't know where that is or what time it is, figure it out, because I ain't going to do it for you. I don't know where you live. I know it's 8 o'clock my time, and I'm the west of him. So, yeah, the shit show is out there. What's the shit show there, Luke? Why don't you tell us a little bit about it?
Well, just kind of a quick rundown on it. It's blue-collar talk for blue-collar workers. I mean, to basically sum it up, we talk about their upbringing, who kind of installed their work ethic, what kind of jobs they've had over the years, where they're at now, what they're doing, kind of get to know the family background a little bit. I mean,
yeah. That's how I see it too. I know Joe Slick Studios is promoting your site and vice versa. We're, in cahoots with each other. And I've been on it before and a couple of times. And, I assist you wherever I can to make sure that thing becomes successful and it remains fun.
Yeah.
It's more about having fun than it is anything else. And there's a lot of great information that I've learned about trucks, about farming, about ranching, about cattle work, ranching there. I had no idea what it took to raise freaking 100 cow, man. I had no freaking idea. And I
Yeah, you're
still
married to
don't.
them cows.
Yeah. The story of our lives, I know, but it's okay. Um, there's so much to learn. And then driving the truck, all the different, factors you got to go, not just the wackadoodles on the road, but the ones who are controlling your routes and the ones who are, where you dump off the stuff and pick up off the stuff. And then the government getting involved in the trucking and the changing of things, trying to make it safer, but in turn they make it harder. And unfortunately, it's hard to make a dollar.
And they've made it worse.
Yeah. And I don't know that they made it easier or safer on the road, because I'll tell you, the truckers scared the crap out of me. I just try to give them a wide berth. But there's some wackadoodle truckers too, and perverts and the like, land of the lot lizards, and all that. And seen plenty around the trucker stops around here.
Local truck stops there in Kingman.
Oh yeah, big time, man. We had 2 big ones that I've seen, and plenty of lot lizards. And crazy. I know there's like 3 or 4 of them big ones, but there's a huge one right there, the Flying J or whatever it's called. It seems like that's where all the hotels are, and that's where all the fun is, I guess. But yeah, that's happening. So it's not just driving trucks. It's about what the trucker kind of experiences, and that's kind of why I think it's a worthy endeavor with what you're promoting and putting.
I think there's a lot to learn from a lot of different aspects in different jobs.
Right.
I got a couple people that I'm trying to get on. It's just conflict with their schedules right now, but
and we can always record it earlier and then play it, so that's not an issue. We just go live and then I record it and then replay it. And so if that's the case, that they can't get there on 9 o'clock, but what we can do when we play it at 9 o'clock or 10 o'clock your time, is be in the chat live. Do you know what I'm saying? Being able to answer the questions. And so there's more than one way to skin a cat,
Yes, sir.
So it's all of that. Where the hell is it? Trying to get you the emotes. Okay, I got it there. Emotes. Oh, there it is. All right. Big. All right.
Yeah. Anyways, I appreciate the free advertisement.
Always, buddy. You know that. You're my brother, so we're family here, so we try to help one another. And let me share with the screen window. Or can they see that? Where the heck would it be? Oh, right there. There we go. Share that one. Yeah, this is his show there. I'm working, getting the things working and on timing here. But yeah, there's the shit show. It's with Luke Klimmer, 10 p.m. Central Standard Time. If you don't know what time that is on yours, figure it out. And yeah, we'll talk about the other sponsors at another time.
Yes.
But, yeah, but it's always good. Make sure I close down all these little other windows. Yeah. Where is it? There we go. All right. Sounds great on YouTube. Okay, super. Cool. I don't know how Facebook is going and the other ones, but Rumble. We're on both. So all 3 channels. And we're recording here as well. So let's see. Where do I want to start? Professor Nick, out of CWU, Central Washington University, is in the middle of research. And in that research, he's talking about the current talk is about the Idaho batholith. Basically, it's the entire West Coast not existing from the 706 line west. That means a major portion of Washington, a major portion of Oregon, and parts of California that don't exist. And the Yellowstone is off the coast of California, the hotspot. And the supposition is the hotspot created a couple of islands, huge islands, much like it did over there in Hawaii. So how Hawaii islands are made, that the hotspot or the what's called the Yellowstone hotspot created these huge islands, and which actually are more continental like, and not as big as North America, but large enough that when they come aboard, when North America crashed into them, when they crashed into North America, they created one, the Rockies, two, the possible Idaho volcanic arc, the Chalice magmas and how that works, which is result after, and then later on the Cascade volcanic arc, and a little bit less important to Professor Nick because he has no idea. It's his words, not mine. No idea what the connection to the Sierra Nevadas are. He's got kind of a supposition idea, but he's exploring, and how it comes into play, between 180 million years is not the window that he's talking about. He's going to be talking about, I think, basically 50 million years ago and current. And the numbers that I've been working with out there is pretty crazy. See, the scene is this. The 706 line is basically a line that comes from Canada all the way down to the California coast, to the California coast, but it's kind of like a concave bow almost to Idaho. And so most of Washington don't exist. Most of Oregon doesn't exist. But what had happened is when these lands came in, these islands, big giant islands, island arcs like Japan-size islands, okay, or Indonesia, PNG size islands came in there, somewhere between there, maybe even Hawaiian size, who knows? Came in and were accreted, added to North America, and so in doing so, as it smashed up against North America, the sea level was lowered, and the land between the island and the North America, as it crunched, built up on top of each other. Kind of like if you took a stack of pizza boxes or frozen boxes and you stood them on end, they'd all be standing up. But if you tipped them over to one side, then that's how the landmass kind of rose up, one step on top of another, on top of another, on top of another, as it broke free when these two provinces in North America crashed into, creating the whole West Coast. The study about, in my mind, studying the West Coast is trying to understand why these earthquakes are happening where they do, and what predicates these earthquakes, what's initiating these earthquakes, and why do they seem to act upon, some huge ones act every 100 years, some 50, and some 300, some 400 years. And where are we in all that mess? That's kind of like the larger picture. But so there's that kind of study that's happening with Professor Nick in the courses that he's had. He's had 2 classes in the Idaho batholith, and there's another one in what was it? Probably 2 years ago. We had a nice chalice magmas, and is basically from Yellowstone westward about 200 miles, 400 miles. There was an event that happened within about 10 million years that a whole bunch of magma came to the top. I mean, drove the land from way down deep, some 100 or so kilometers all the way to the surface. Something happened. And in the reason they say they're that old is because they've done, magnetic testing, and the type of rocks that exist only exist in certain kinds of events, such as a subduction zone. And after it's subducted, it got lifted up all the way to the surface, which is really crazy. And it's morphology and how rocks were morphed into, other kinds of rocks, and all of these things. But that his course that he's going to be teaching starting November is talking about the Cascade Range of volcanoes. He hasn't done an in-depth study, but he belongs to a group or 2 groups of geologists that are researching in these areas, and they've been on talk show on his courseware or interview, like much like the Rabbit Hole here, and how he's explored different ideas, such as parts of Washington, and even up in Alaska, parts of up there in the armpit of Alaska, the Gulf of Alaska was actually somewhere down in Mexico. And the idea that the whole West Coast from the 706 line, or maybe even further back, to maybe the Wasatch, was actually shifting north while everything else was shifting south or going west. And getting the times and the dates, that's what's critical. And that's something that I've been working on, and working on some videos to try to get a gist of what was being said here. Turn that off, will you? There you go. And trying to see what's going to happen in 10 million years with the Wanda Fuca. And I've got something that I'm going to play for you. But first, we're going to also be going to my boy Canuck and what he's been doing and what he's studying regarding the events at California, Nevada, 2 parts in California, one on one side of the grapevine, one on the other side of the grapevine, and then Nevada, which is further out, all part and parcel of being around the Garlock Fault. Garlock goes right down the middle of this discussion and what's been happening over the last 2 weeks. There are a lot of people that like to create the fear and the crap like that. It's not what we're trying to do. I think by understanding and researching these things and reading the papers, reading other people's in-depth studies, who are a lot smarter than us or have a lot more time on their hands or have spent 20, 30 years studying these areas, and we can glean from them what the heck is going on and test if their theories and articles are correct. And in discussing those types of things, that's what we plan to do. And then also we will tell you that Iceland's still building, and they're still trying to build up the walls, and the land is slowly inching upward, and it's not very fast, but it's on track to erupt again here in the next week. So they believe, the last I heard. And I don't know, Canuck, have you heard anything in regards to that?
Yeah, just from today, they said it
Go
could be any time. They're just waiting for the earthquakes to increase because they've been increasing the last, I guess, week. But it's staying pretty steady. They expect it's going to spike like a whole bunch right before it erupts, like what it did last time.
Right. So it's on track to act just like it did before.
Yeah.
All right.
Are they saying the magma chambers?
Yeah, they
Pretty
think
full-
it.
pretty full
Yeah,
now?
they think it has at least as much in it as it did from the last eruption. So, 20 million cubic meters. So same as what it was last time.
Right.
20 cubic meters. So it's gonna be about, when the eruption happens, it'll be about the same than what you're saying, right?
Yeah. Well, if it waits a little bit longer, there might be more come out, right? So.
Right. Well, right now, the solar wind is at 376. Proton density is at 6.8 protons per cubic meter. We've had an X flare, an X1 in the last 24 hours, and a C6. The sunspot that kicked off that X is kind of, kind of funky. It was hit right at us, and they don't know if it's CME. They say a faint one maybe be coming right at us, but they still, it will strike Earth around the 17th if it does. A NASA model predicts it. Yeah. Okay. Let me see if I can share that with y'all. That one right there. Okay. So this one has to go with this one and show on screen. There you go. So this is the latest, and it's pretty fast print. There's the boomer coming right at us, around the 17th, they look like they can get us. This is from NASA, I believe. Spaceweather.com, yeah. NASA model. So we'll see. Because it is directed right at us, we might get a G1, G2. Who knows? But AR 3784. Normally, the magnetic is over here on the left. It's down below. So they're kind of thrown by that. Violations of Hale's law is due to happen at any time. About 3% of all sunspots reverse polarity, positive, negative, instead of negative, positive, or vice versa. However, 3784 is neither normal, positive, or negative, positive.
What happened?
No.
I don't know what happened. The site went down.
Is that what it was?
Yeah. Are we still on over
Yeah,
there?
Yeah, we're still on.
Yeah, we're on here, but I want to know, Timmy, I don't know what happened. It just kicked you all off at once and then came right back.
Yeah, that was weird.
Yeah, I wonder if we just had another flare. Let me see here. Go to X-rays. No, we didn't have another flare, so we're okay. And you all see this, so I'm not worried about it. Yeah, but this sunspot's the one that gave us the X flare, and it's pointed right at us. So 3784 right there. Boom. It's a little bit in the north. Here's the equatorial region. So it is maybe just over the top of us. On the backside, though, I heard something or read something about the backside's got some more stuff coming at us. There are two sunspot groups on the far side, the sun, who's that are affecting the way the whole sun vibrates. Suggests that one of them turns towards Earth this weekend. The appearance of another big sunspot group will keep the sunspot numbers elevated to the 20-year high that it's already in. And the KP is quiet right now. 75% is for an M, 25 for X. All right, so that's as far as I'm going to do on that. That's Google Earth. This is EMSC. The latest is 40 Oaxaca. Costa Rica had a 4.5 in Argentina. It happened, and it's pretty deep, 129, so maybe not too much pain for them. But what else? Nevada had another quake. Another quake in California. An aftershock happened at 4.2 Miramar today. What else? I'm only going 8 hours tonight. Costa Rica 4. Vanuatu had a 4.9. Central Peru had a 4.3. Eastern PNG 4.2. So and then Chiapas had a 4.4. Those are the big quakes. 4.7 in Hindu Kush region, Afghanistan. That's 7 hours ago. So that's all up. Well, and we're talking about, the Russians. We may talk about that too. I don't know. Canucks getting on top of that, and I've learned a little bit, but we'll see. What else? Do you want to talk about California and what you learned through your readings today there, Canuck? Or
Yeah, I was focused today on Puente Hills, but to talk about up by Bakersfield first, they think that was on an unknown fault just north of the White Wolf Fault.
Okay.
So that's what they've concluded with that so far, but they haven't named it or gone in detail anymore about it other than that.
Yeah, the White Wolf Fault, as we're looking on the map, comes out of the mountains and it stops about where they have it stopped right around where the 5 freeway is. But if you continue that further on, you'll see that there are faults there, but they don't have them labeled as a White Wolf.
Yeah, and that was the quake last week, whatever it was.
Right. This is the White Wolf Fault here. And if you continue it through, Wheeler Ridge Fault is down here. Then there's all these unknown named faults right here at the bottom. And then you have the Prieto Fault, which is a northwest to southeast fault. The White Wolf Fault is a northeast to southwest that crosses to the bottom of where Wheeler Ridge is and then into the San Andreas. The White Wolf Fault is a very active fault. A lot of little quakes happen. And out here, are right here on that spot, I mean, you can almost throw a stone how far away it was. Probably 1 or 2 miles. In 1952, had a massive quake right here. And I think it was, a 7.4, 7.5. One of the largest quakes in California history happened. And it also happened in, 1872? No, that was the Owens Valley. I think 1852 as well, or 1850s or something, if I'm correct. I don't know about the dates on that. Are you aware of that, Canuck?
Yeah. Yeah, because 1952.
Yeah, 1952 was the earliest
Very
one, but
choppy.
there's one before that in 1800s as well.
Yeah, 1857
1857, yeah.
was the Fort Tejon one.
Tejon, which is right up here at the top of Frazier Park. And that's where the Wrightwood out here moved so dramatically that it's believed in that 1857 quake that the San Jacinto Fault, which is roughly, 100 miles long, or if not more, maybe 150 miles from, got a 4.3 in the, already dropping, south of Fiji. It just popped up. The San Jacinto Fault went at the same time the San Andreas that was up here at Tejon. And I want to say there's also thought in 1812 that same thing went. Am I correct?
Yeah. 1812s, I think more than one went. There's actually a paper that says because of the 1857 Fort Tejon quake, that's why San Jacinto, all the bigger quakes on San Jacinto since 1899 are all as a result of that 1857 quake. Because how they've done the segments for the San Jacinto, they said it's like adjusted, like alternating, coming down since that 1857 quake, beginning with 1899 San Jacinto.
As a result of the 1857. So the 1857, right here in Wrightwood, or up here at El Cajon Pass, it moved 200 feet.
Yeah.
So massive movement up here. Now, normally a 7.1 moves 15 to 16 feet. A 7.3 to 7.45 will move between 17 and 19 feet. But this thing moved 200. And that's freaking amazing, because and he's talking about the I think it's the 1812 quake that moved so massively. But the 1857 is a response, the 1899 is a response, and the 1952 is a response to all of it together, with the San Jacinto fault moving on the San Andreas. It is all part of the San Andreas system. There is several major faults, and I guess they find new ones every day, right?
Yeah.
But continue. What else did they find?
Well, the next thing I'm going to talk about is the current quake that everybody's all interested in now, which is the one there that happened right in near Highland Park, I guess was the official location.
East LA. Yeah.
So anyway, so when it first happened, Caltech thought it was on the Elysian Park thrust fault, but since then, both Caltech and USGS have decided it's on the Puente Hills thrust fault. And so that's the conclusion that they've come to. Of course, everybody's all talking about it now because Lucy Jones went on and did her spiel. And so now everybody's interested in that fault. So in the last, 2 days, everybody's all trying to figure out what this fault is, because nobody's looked it up before, even though the media's all freaking out over it, right? But the studies have been out since they actually discovered it back in the late 80s, early 90s. But all the studies now, the media is all noticing. So what I'm going to do is put the link to the Wikipedia article, and then I'll talk about it more.
How far of a distance is it from the first fault that they thought it was on, but now that they're saying this other fault?
They're all pretty close. Like, I'm not going to get into all the other ones now, but there's a whole bunch of thrust faults that are under LA. But of course, everybody's just focusing on this one now because that's the name that the USGS has said. Like, I could do probably a 5-hour show just talking about the thrust faults, and you could do even more on the regular faults, but now everybody's all worried about this one, so it's all the big focus right now.
Yeah.
So
the two quakes are about 110 to 115 feet or miles apart. Okay, you have two quakes. The one quake here is a 4.4, and the other main quake, I don't remember what it was. Well, I disagreed with him, but I think it was over a week ago. I think it was a 5.2.
5.2. I was going to say.
Yeah. I guess I can do 30 days and it would show me. Yeah, there it is. Yeah, the 5.2. So, and we'll go like this. So we'll keep them all in the same boat here. Okay, Canuck, go right ahead.
Yeah, so I put the link in there, so I'm just gonna talk about it.
All right, let me grab the link.
And it has like all the diagrams in there explaining where it is. And
Okay,
all that
good.
stuff.
Is that the diagram you want to see?
Yeah, the first one is what everybody's using to explain.
Okay,
it
cool.
there.
So go ahead.
So basically, it's up along there. It actually goes over the top of where the Whittier Fault is, which that's how they found this fault in the first place, because it was from them studying the 1987 Whittier quake.
Yes, the Whittier Narrows quake. Yep.
Yeah. So when they were trying to find out which fault it was that was on, that's when they found out about this Pointy Hills fault. So there's been a whole bunch of different people that have studied it since. So it goes back to like the late 80s. And it's not like a super long fault. It's only like 40 kilometers. But based upon how it is and the angle of it and stuff, and because it's a blind thrust fault, so what that means, blind means you can't see it at the surface. Like there's no evidence of it at the surface. But so it's not like the other like a regular fault, like Whittier or Elsinore or whatever. There's traces of it at the surface that you can see.
Right.
Yeah. But they found it with all the stuff they can do now, right? So they found out that it's there. And it's not the only one, but they're worried about this one.
Screen.
Yeah.
I put on screen what's a transform fault, what happens during a transform fault, a Horst and Graben, or it's a spreading fault, or a thrust fault. And I put it on screen so you can see what's happening. And he's talking about is one is being subducted underneath another, and the power is this one being pushed over the top of this one. So that's what's happening in a thrust fault.
Yeah. And so they're worried about it because they've done enough studies on it. They figure it can make as large as like a mid 7. And they think it's done that over 4 times over the last 11,000 years. So it goes off about, every 2,700 years or so.
Yeah, pizza boxes. Kuwait Cat, you're mentioning a subducted pizza boxes kind of thing. When you have uplift in one, and that one gets put on top of the other, pizza boxes, basically.
Yeah, and it lifts stuff up. To simplify it, where the thrust faults are, they found most of them because it's where the oil fields are. Because the thrust faults lift up the oil so that we can more easier drill to it. So that's why if you look up all the thrust faults now, they usually have a name of whatever hill or oil field the hill's on. And so they've been discovering these thrust faults mainly since, probably the late 80s, early 90s. So that's when they started finding them, when they were looking up quakes that happened, they thought, on the other fault, on a regular fault. But then they find out it's like Northridge now. They say Northridge was on the Northridge thrust fault. So there's another example. Most of the quakes that have been recently, like say in the last 20, 30 years, they're finding they're all on thrust faults when they start looking into it.
Right.
So that's example. But they're worried about this one because it can make a 7.5 and it's right under like the most populated part of the LA basin. So that's why they're so worried about it. So they have actually quake sims on it that they've done. So they've calculated how much damage it would do if it had a 7.2 to 7.5 there, and it's like $250 billion or something.
Billion, yeah.
No, 250. So it's like
basically what's happened is in a thrust fault, it's these parts of land, right, that gets pushed up over this part that exists. All right. This is all happening underneath the ground. The brown part up here, that's the surface. These thrust faults, they don't know they exist because it's happening below the surface. it's not visible. So what happens is, I want that one. I want this one. What'll happen is this fault right here will rip, and it's overriding, this part of the land. So this part of the land is subducting, and this is riding over, and that's the thrust. It's being pushed over the top, and then you'll get another thrust fault here, or even up here, and they'll name these thrust faults, like Elysian Park or Hollywood Hills, or Whittier Narrows. They'll name these types of faults because one, the area, that's the geographical area, is where it's located, and generally speaking, it's where these faults are between the plate boundaries is where they find oil. That's where the oil deposits are. And so what they're doing is they're drilling down, sucking the oil out of these areas. And wherever, let's say the earthquake happened right here, if this is the Point of Hills, actually you can't read that, of course. If it was the Point of Hills fault, they would call it the Point of Hills fault, or a shear zone, or Pointy Hills. And that's where a bunch of drill holes are, and they're sucking the oil out of the ground. And I think that's what you're saying. Am I correct?
Yeah. So the thrust fault is what actually makes the hill, that lifts the hill up.
Mm-hmm.
And then that's where it also brings the oil up into the pocket, or whatever they call it, so then they can drill to it. Because you'll find, if you look up like all the thrust faults, you'll find that they're either named after the hill,
Mm-hmm.
or after like what the oil field that's on top of the hill.
Right. And what I'm putting down here in the gray, these are sediments. Over time, a lot of these faults get hidden because of the hill being made there, where let's say one fault is made, but over time the erosion will make it just hidden, and they don't know it exists because
I'm glad you explained that, because I was just going to ask you a question similar to that. What's covering these thrust faults? Is it sediment and silt?
There's a lot of sediment in the greater Los Angeles area, because it's a watershed. The whole Los Angeles is a watershed through there. And the uplifts that are happening, there's some theories that I'm aware of where there's a belief that Los Angeles sits on a group of thrust faults that they themselves, if something were to happen, would fall, and this would sink quite a while. And the old adage, LA is going to sink into the ocean. They're looking for answers, and these are the thrust faults that lift up. And there's a lot of hills in the greater part of Los Angeles, and the Point of Hills. Let me show you on screen here. The San Gabriels are right here, I think, right here, and these are like over in front. Malibu is up this way, and then this is like further south, of course. I think that goes way past where I'm at. That'd be Santa Ana Mountains, and then Big Bear's up that way too. But I think it might be on the backside of Big Bear's. Might be backside of this frame, actually. These are closer, uplifted.
Yeah, I think, to simplify it even further, probably any place you have a hill that's of anything is probably related to a thrust fault, because at some point something happened there where it lifted it up, whatever reason it lifted it up.
Right. And it's interesting. You have a couple of different types of things going on here. You've got northwest to southeast, all these faults along the San Andreas fault zone. But then you got these ones that go east-west. And most people only think about the San Andreas. But these east-west faults like this one here. I see the what is it? Not the Santa Maria, but the San whatever it's called.
San Cayetano.
Sierra Madre goes
Sierra
all the way
Madre.
through there. As I'm showing you on screen here, there's faults that go right along this mountain range, but this is where the earthquake is, and this is the one we're talking about. And you have the Elsinore fault, which goes all the way out of Mexico, which is longer than the San Jacinto. It moves all the way into, El Monte, Pasadena, and it's a super long fault. La Cañada, Flint Ridge, all of these quakes, San Fernando, and up into Santa Clarita. If you just follow that fault, it goes all the way through. And it's part and parcel of the San Andreas Fault Zone. And a zone means a series of faults that coincide or are related to the main fault, which is, it's a major one. And
and if you go on the same angle between the quake at Bakersfield and right there, if you just continue that on, they actually look to me like they almost intersect.
Intersect, yep. And Fraser Park's at the top, Lebec at the top, that's Tejon.
Yeah.
Not Cajon. Cajon's over here, or actually right through here. This is Tejon. And at Tehachapi Mountains, that's where, in this area, massive subsidences happened. You're talking 30, 40 feet in some places, and on average 20 some feet of a complete telephone pole, dropping in the last 50 years. So it's pretty significant subsidence. In addition, there's a ton of oil well drilling along the Temblor Range, through here, and the Caliente Range, and the Fraser Park, and the Tehachapi. Ton of drilling of oil.
Well, I think there is in Puente Hills too.
Yes, there is. In the greater Los Angeles area, there's a ton of oil being drilled. Has been for 100 years. The San Joaquin Valley, the historical age of the San Joaquin is that it sank at least and rose about 8 times. That means it was under sea. Sediment came in, it filled it up, it rose, and then it sank. Sediment came in, filled it up, rose, and it sank. Or the water level of the ocean rose and sank, rose and sank. So the age of the San Joaquin and the Sierra Nevadas are 120 to down to 80 million years when they were being made offshore and maybe came ashore, or a volcanic arc from a subduction zone, a westward subduction zone, creating them. It's still up in the air. It's still being argued, still being discovered. At a little bit different. It precedes the Cascades, but
are these faults that you're talking about, are they all capable of producing like lower to mid 7s?
Yeah.
Some they say high 6s because they say the Elysian Park one, which actually goes right under Dodger Stadium,
right,
can make a 6.7, same as the Northridge quake.
Right. And
so it just depends on which one you're looking at. The other one is almost as bad as Puente Hills is Compton, the Compton Thrust Fault, which goes right under Long Beach, and Palos Verde Fault, which they have all the new studies on, is basically right next to it. So it's pretty interesting.
Yeah, LA's got some major stuff. The Rose Canyon Fault that turns into the major fault up here, the Huntington Beach Fault, Palo Verde's Fault, and the Newport Inglewood Fault. Newport Inglewood turns into the Rose Canyon. You can see it's all the way past, this is from San Diego or even TJ. It comes down here all the way up into Los Angeles. One fault.
Yeah, so they
There's
say
many sectors.
Newport, Inglewood, and Rose Canyon are all connected now. So if
Right.
you look up all the new stuff on it, they refer it all together. So that means it can make like a mid-7 now because it's long enough. And because part of it's offshore, depending on where the quake is, it could make a tsunami too.
Mm-hmm.
So it's crazy stuff. So San Diego and LA could both get taken out by the same
Same
thing.
earthquake type thing, yes.
Yeah, depending on where it was. Like if it was in between.
You got to remember that story of the 1937 vision a kid had?
Yeah.
About Los Angeles, about San Diego, about Mexico, about Colombia, about San Francisco, about all the way up there in Washington as well.
And
So-
there's a debate now about the 1769 quake that the Spanish explorers, when they came inland in the LA basin, there was a quake that knocked them off their feet. So that's the first one that the Spanish recorded. So it was like summer of 1769, July, I think it was. And they've debated now where that quake originated, because first they thought Newport, Inglewood, but now they think it was like one of the thrust faults farther in.
Yeah, that's what I've gathered too. Is further in than Newport, Inglewood, but depending on exactly where they were, if they were, cutting trees down, going inland, where all the, there are certain native people that lived in the area, and
yeah, they were going, I think, to meet the native people that were there.
right. And
because they'd already been down farther and talked to them, like down in Baja and all that. They were all up there before they came into the LA basin itself.
Right.
So with that quake being figured maybe farther inland than originally thought, does that make the quake bigger or less?
Well, no, but yeah, but
it's hard to call.
When they study each one, they're finding it will make a 7. The only problem, if the one is off the coast in the water, then that's an issue, right? Because you could get a tsunami. But
we do get liquefaction here in Los Angeles greater area too.
Yeah.
Or there, I don't live there no more. I don't know what the hell's going on here.
But basically, that's what they're finding. So there's more faults that you need to be aware of than what the general population knows about. Where it might be always focused on San Andreas or San Jacinto or Elsinore. Those are the ones people probably know. But there's a whole bunch of other ones that you have to worry about too.
And the orientation of that, I think you have it here. It's northwest to southeast. Why is there this crack or this kind of lightning bolt thing here? Is that part of that, or is it just somebody added that to make it look like that, or is that what they think that fault looks like, the uplift? And
as far as I know, from their tomography or whatever they've done on it.
See if I can blow this up here. I don't think I can.
Like there's other papers that go into way more detail what it looks like, but they're super complicated. Has all the diagrams in it, shows how they all intersect.
Yeah, see, the Sierra Madre fault is one of the main faults, and then the Puente Hills fault comes through, and then the Compton fault. I'm looking at it. It's progressive, and it's uplift. It looks like the Sierra Madre lifts the mountains. Puente's, this section here, there's the 1987 fault or earthquake anyway, goes under the mountains of the San Gabriels and lifts them up. They're not small, everybody. They're very large mountains, and they're 100 miles to the shore. It's, you wouldn't believe it. Just like you're driving down a flat land, you look over and you got to kick your neck way back up at the base of the mountain. If you haven't driven in LA or the greater Los Angeles, San Bernardino, Riverside area, it's a trip. Just how big these mountains are and how close they are to the ocean. And a lot of the area of Pasadena is about 2,000 feet above sea level. But when you get down into a lot greater Los Angeles area or right in Los Angeles, you're 50 to 200 feet above sea level. So it goes up pretty quick.
And then we have to remember that all these faults are actually intersecting each other down farther in the crust. Because if you look at it from a 3D thing, like we think it's, and they're not all the same angle because the crack or the fault's different angles. So it may be intersecting with another one that we don't think it is farther down, because that's how the crack or fault is all intersecting. But they're getting better at it, because with the tomography now, they can actually do that and see where they actually are, and see, because the newer studies have all that stuff in it. So they'll do like a 3D section. It'll show you that this one is coming down at this angle, and this other one is going underneath it or through it or intersecting it or whatever, which that's why they're finding when they do all these studies now, they say this is why a quake on this fault here sets off another one that's next to it or down below it or above it or whatever. That's what it's actually doing. So the stress releases on one, and then it causes another one to be more stressed, and then it releases, and then you get a sequence of quakes. Kind of, well, how Ridgecrest went, because there's two close together. The whatever 6.5 and then the 7.1. And it was two different. The 6.5 was on a different fault than the 7.1 was on, but one caused the other to quake. And that's what they're finding everywhere, basically, when they do this stuff. And same thing in Turkey.
Yeah, you know what's interesting?
Turkey was three different faults, actually.
Yeah, all the earthquakes that they're talking about in the last, 50 years, I've been in on this report. Yeah. I felt every single one of these faults is earthquakes.
Yeah, because that's what they're finding. Most of the ones in the last 30 years, they thought it was on such and such a fault that they knew about. But when they started studying to find out exactly where it was, they said, "Oh, well, this is on this new thrust fault." And I'm pretty sure they found out that the Loma Prieta quake was the same thing. It was on a thrust fault. I can't remember the name of it, but when they actually looked into it, that's what they found out. So they found out most of these big ones that been on the west. Well, it's probably a lot more than that. It's probably like everywhere. If they really look into it, they're probably finding it's a thrust fault.
The orientation is what I was looking for. The north is, upwards to the north, top of the page, because it's not going to let me blow it up. I don't think.
But
okay, I can. Cool.
There's been a bunch of people looking to find out when the last time Puente Hills had a 7 or 7.5, but we can't find it in any of the stuff. And there's been a bunch of people looking already just in the last few days. They just say there's been 4 in the last 11,000 years. So that would be every 2,700 years, basically. There's a 7 on that, but they won't say when the last one was from any of the things I've looked at so far. So now this has created a whole bunch of questions, because all the people that read the fault studies because I know a couple of them have said they were trying to contact the USGS and Lucy Jones and find out, well, if you guys know if it's 4 times in 11,000 years, when was the last one? So we can try and do like what we're doing with all the other ones, trying to figure out the frequency about how often it goes off, and then how far away are we from the last time it did something.
Correct.
And so now this is
it repetitive, and that's what you and I study all the time, do here at JSL. Many of our people do that. They look to say, okay, this has happened before. What led up to it last time? What's leading up to it this time? I want to make a comment here in regards to this. You can see the red color is shallow, the blue color is deep. The San Gabriel Mountains are super tall, but you see the subduction right there, the Sierra Madre. That's a subduction thrust fault, right? So you can see the orientation. And they just took a cut out of it. That's all that's on right-hand side, the left-hand side. Lower Elysian Park, right? And then up on the the top there in the San Fernando Valley. This is just
Yeah.
a snippet, but you can see the Compton Fault there on the bottom, the Puente Hills, and the Sierra Madre. And you can see that the Compton, what rides over the other. The teeth always point to that, I believe, that's subducting lower. So it's like eating something, like going over the top. But I might have it reversed. But anyway, you see it northwest to southeast, northwest to southeast, northwest to southeast. And
how often do, like, you guys, they get a quake in one of them faults? How often is it in a short amount of time that you get another quake on an adjoining or adjacent fault close to it?
well, you can look right here. 1971 on this map is right here. You can see my mouse swirling around it. I felt that one. It knocked me out of my bed when I was a little kid. Here's a 91 quake right here, right? And then here's a 94 quake right here. That's the big quake, 6.7. Here's the 1987 quake. All on these faults, they're within a few years of each other. And some other faults or earthquakes aren't on these, but in the 90s there were a fair amount of very, very, very strong quakes. 71 was a pretty good quake, and there are other ones that are fives. 1987, I think that was the Whittier quake. The 1994, that's the Northridge quake. 1991, I think that was the I know 92 was Landers, but 91 I think was right up there next to the San Gabriel Mountains in the Fontana area. So there are really good quakes, and that's why I said in the 90s they were quaking all the time. I mean, it seemed like every couple of years we'd have big quakes. However, that being said, I don't understand the 2000s because it's all in the desert, right?
Yeah, so far.
Yeah, from 1999 onward was all in the desert. Now, this area, Los Angeles, Orange County, along the shore, and San Diego, very susceptible to earthquakes. Very susceptible. There's 42. She's out there. Good to see you, girl. I think it's interesting, and I show it on stream here again. The thrust fault, one side's riding up and over the other, right?
Yeah.
And then
That's why when it jumps up,
mm-hmm.
won't be good for the damage.
No. The P wave doesn't destroy things. It's the S wave. That's the shaking. It goes on because it lasts longer. Unless you're right on top of the P wave, because then it like pushes you up several feet or pushes you down several feet. So
besides liquefaction, you'd also get landslides too on the hills.
Yes, sir.
There you go.
And the more they've landscaped the mountains and the hills, the more they've hidden some of these danger zones, and the more that city spreads out, gets thicker and more condensed, the more evidence we see that a lot of lives will be lost when it goes bad. And the Sierra Madre fault is one of those kinds of faults that is super, super big, and it's right at the San Gabriel Mountains, right at the base. And there's a lot of little hills, West Covina's and stuff like that. East LA, Los Angeles Dodgers live in a bowl. And
Chavez Ravine is
Ravine,
in the fault, which I thought was interesting when I started looking that up. I said,
Right.
yeah, they're right down in the hole, so I guess they're not going to fall too much farther since they're already in Chavez Ravine, unless it all falls down on top of them.
Right. But I find it interesting that the Point of Hills fault. This is one you were discussing. We'll go back to it here, show you on screen. The Point of Hills fault. What actually did you glean from the article that you read? I know you're doing a study on Point of Hills, and we did that through Wikipedia, but something prompted you to go look at it, and you've got some current information on the earthquake.
Well, it's just
the 4.4.
right. Yeah, I was trying to figure out exactly where it was
Mhm.
before they started talking about it, because I'd read about it before. Because I read back the thrust faults a while ago, probably 2 or 3 years ago. Because James Dolan, which he's for USGS, and I think
USGS,
he's
yeah.
at USC or one of the universities there. He's the one that is the expert on all the Southern California faults. So he studies them all. Well, he put out different papers. Like he has one that's just for all the ones under LA. So that's when I first read about the thrust faults. But then there's been others that have done like the individual thrust fault studies themselves, or did like a combination saying that there's a bunch here in Southern California or whatever. So Dolan has one where he names like every fault that's under LA. Like I forget how many pages it is. It's like super long because he goes in and
That's
explains
the
each one.
250 pages things.
No, that was the where the Nevada quakes are. I'll get into that later. We haven't got to that part yet. But anyway, he has like this big paper where he lists all the ones. I think it was from like the early 2000s, or maybe it was 1999. I can't remember now. But anyway, I've read so many of them now, they're all running together. So whenever any of these things happen, I try and find out exactly which one it's on. And then I wait to see what they say. Because Caltech was saying Elysian Park fault first. And then they changed it like in 24 hours to Puente Hills. And that's what they've been talking about ever since. And then the media caught on to it. And now, like if you did a search for Puente Hills thrust fault, you'll see all the articles just in like the last 24 hours or 2 days, because now all the media's caught on to it. But the studies on it have actually been out for a while. So you could have read them before, but now everybody's, because the quakes happened there and they're talking about it, now everybody's all interested in it. So you'll see there's videos, people, all sorts of people talking about it, and it's on all the mainstream media and all that till the next quake happens in another spot, and then they get worried about the next one, because that's how it goes.
Yeah.
Then they'll forget about the other one and then move on to the next one, because it's the next latest greatest dangerous fault story, because that's how it works. Even though technically they're all dangerous, it's just a question of when they're going to go off. So,
Correct.
like I could scare everybody. I just start talking about all the other ones, say, well, this one can do the same as this one, and this one can do the same as that one. And what if all three go off together? Because they already know that can happen from the other studies on previous things. So, like, you could just go on and scare everybody all half to death. It should be the scare people to death class at school. They should get it to them early, and then they already know about it. So then, oh yeah, we know about that one. That can take us out. Well, it hasn't gone off for 2,000 years, so
Right.
we're good for another 750 or whatever.
Well, here's something interesting, just an observation, looking at what has happened over the last 2 weeks in Southern Cal. Right. This is just an observation. It doesn't mean it's worthy of anything, just more than an observation. This is the Garlock. Okay. This is the San Andreas. Right.
Yep.
All right. What we have is the Bakersfield quake out here in Ridgecrest. Then we have the Nevada quake, St. George. What's going on?
Yeah.
And then,
well, so do you want me to talk about the Nevada thing? Because everybody's getting all worked up about that.
I know, I got you there, and I'm going to lead into that.
Yeah.
what has happened is in this part from Lompoc to roughly Cathedral City, this portion of the San Andreas is compressional, is a transform. It's not strike slip. It acts different than up here on the San Andreas that goes all the way through San Francisco. It's also the Coachella Valley, which the San Andreas drops out here and turns into the Imperial Fault going south. That part is different as well. So there's 1, 2, 3 different parts of the San Andreas system or fault zone. And this particular area, number 2, acts different than number 3 and number 1. But it appears that number 2 is very affected by whatever's happening in number 1, because as the pressure moves in that direction. And that's why this bend right here in the San Andreas, which is crossed by the Garlock, is interesting. And then you have a quake here, a quake here, and a quake here, roughly in a straight line. So what's going on? And this other quake that happened in Los Angeles down here, it's smaller than this one, but and these are smaller, but it's like back pressure pushing up on the Garlock and that part of the San Andreas where it's compressional. So can it be that as this thing goes this way, right? Can it be that this portion of the San Andreas is actually trying to slide up and over this way, and some of it being slid this way? And if that's the case, these systems that are out here, the Landers in 1992, the Hector Mine, what's also happening out in Barstow recently, these breaks that are happening out here could be associated with pressure being moved that direction, eastward, thus putting pressure up on this area just outside of Las Vegas. And this transition area, the transform fault, moving from one kind of fault to another, is very interesting. And it almost acts like part of the desert out here wants to go this way, and part of it is being forced up the San Andreas because the Pacific Ocean move in that direction. So that's what I'm observing. Do you have anything you would add to that, Canuck? I mean, what are your thoughts on that?
Well, people have been noticing when they looked up the quakes on USGS there in Nevada. And I can't remember one of the ones I was watching. I think they went back 7 days. I think it was 7 days. And they noticed there was a northwest to southeast line coming right down there, heading towards that, whatever the name of the place is. Indian Valley Springs, I think it's called.
Yeah, Indian Springs.
Yeah, Indian Springs. Yeah, Indian Springs. So the person I was watching wasn't looking up the fault names, but of course I said, well, I'm going to do a search for faults in that area, and come to find out there's a fault there, and guess what it's called? Well, it's Indian Valley Springs or whatever. So it has the same name as the town, and it's they have valley in the name too, so it's that whole entire valley. So that entire valley's been quaking, like coming down towards it in the last 7 days or whatever. So then once I found out that was the name of the fault, I said, well, I'm going to see what I can find out about it. So I started doing a search, and it wasn't very easy. I kept looking. I couldn't find anything that was giving
30 days.
Yeah, that was giving me like super specific information. So I tried going a little deeper into it, and then I found a thing that it was done by the Nevada Bureau of Mines and Geology, because they're what do everything with faults and everything in Nevada. And this study that I found was from '96, and it was done any faults within 100 kilometers of the nuke test sites. That's what it was based on. So I don't even know how many faults there were. The study itself is 250 pages and it lists them all. And you have to scroll down through all these pages, find the name of the fault. It's all in alphabetical order. And then it has information on each one. So I tried to find the full 250 page thing, and all I could find in all the things I looked up, the most it went was 160 pages. So it never got down to where the
That might
Indian
be
Valley one
designed
was.
there too. It might be a national security. You ever
Well,
thought
I
about
don't think so, because they would have done it for a specific reason. It's just I haven't found one that has all 250 pages in it yet. And
Yeah.
otherwise, if I found that, I'd be able to find it, and it lists like how many quakes it's had on in the past, what its slip rate is, like all the normal stuff. So that information is out there. It's just a matter of me finding where I can actually get to it. And that's what I find with all this stuff. It's just you got to dig and find it. And if they haven't done studies on it since, well, it's right next to where the nuke test sites are. So, and it's right by one of the bases that's there too. So maybe they don't allow them to do any more tests on that.
right.
Yeah. But that's probably what's going on. But I was surprised when I went into this thing because it had them all listed alphabetically, because I could see in the stuff at the beginning how it had them all listed in the table of contents thing. And I said, well, look, I have to go way down to page 234 to even find the one that I'm looking for, because it's all alphabetical. So I started scrolling through them all, and I got down to the thing, and the biggest one I could find only went 160 pages. And I said, well, that's ticking me off. And I tried 3 different places to go and find out about this fault that's there, that's quaking right now, that everybody's all worried about, because it's like pointing like an arrow at Las Vegas. So, the people that are watching are saying, what's out there? We don't know that there's a fault there. Why is it doing that? So of course everybody's
Yeah.
coming up. Oh, they're blowing up dams. There's underground tunnels. They're all freaking out. And here, all it is all about the faults.
It's the battle of the white hats and the blue hats, black hats again, huh? Wow.
Yeah. So that's what everybody's all freaking out about it. But they're all concerned because it's kind of pointing like at Las Vegas. And like anybody that knows about the faults there that are around Vegas, they say, well, yeah, that's how they are. They're northwest to southeast. But they're not going into like a big detail on the actual fault that it's on. So I just find it funny.
I'm looking at them right now, and they're northeast to southwest. All of these ones up here. This is the last 30 days of earthquakes happening. So as what Canuck was saying, that there's been a lot of quakes in the area. In addition to that, I've noticed that the Wasatch Fault has gotten busy. These quakes in the last 30 days, all the way into St. George. I'm like, hey, but we've been noticing the backside of walkers over here. This would be the Texas liniment. The Texas liniment has been busy for some time. Even in 30 days worth of earthquakes, you can see a clear pattern persisting. And is it the basin and range? Well, if that's the truth, why isn't there the quakes up here? Why are they right here? Well, it's just the basin and range. No, they're not. It's not just the basin and range. Something's happening.
Well, it's the eastern side of Walker Lane and the western side are both going.
It's the chicken leg being swung out this way. We're being pinched right through here. This is a push up, and this way is a push over. And that's all this stuff. That's what I think is going on. The chicken leg is just the Pacific Ocean moving north. That's all it ever means. You see pressure on this side because the subduction zone being brought over. It's cracking right here. Over here, we have the plate boundary. So, of course, you're going to get quakes on that. But look at these ones out here. Here's a line of quakes. Oh, yeah, they're drilling. Are all the quakes because of the drilling?
No,
I think it's just what it does. because
the Madrid zone is active.
Yeah. Yeah, you can actually look in each area. You can look up the quake, see what depth it is. Then you just have to look for whatever the oil field that's there. You just look up what the average depth of the wells that are there. Sometimes there's some that are super deep,
Mhm.
but most of them are
there are two different kinds
not
of wells that I'm aware of. One is made for fracking, where they put water down one side, dig another well, and they bring the steam up that other one. So they either put down the sludge or whatever they want to do, bury down there, turns into whatever, and on the one side. Then there's just drilling a one hole, sucking it out. So as far as I know, when they're and they separate the wells because they're expensive to do, they separate them and they put a grid on them and they hit them with the grid. But the fracking ones is where they're putting stuff into the ground to break up the shale and get the oil out of it. But interesting to say the least. There are patterns that persist, and these are just 30 days in North America. And you look up where all the vibrations happening up in Washington, up by the Olympic Peninsula there. You see all the stuff that's happening down in Klamath, which is the top of California, of vibrations that it appears the subducting Mendocino Ridge virtually is the Walker Lane that goes down and under the backside of the Sierra Nevadas, which, over the past year or 2 years, we've seen a lot of quakes happening right up through here in this area, Northern Cal. And it's, this lake right here. Where is it? Yeah, right there. The Lake Almanor, whatever. Right? Lassen Peak is right next to it.
Yeah, because there was
Shasta's right here.
Swarming out Lake Almanor there not too long ago, back a year or two ago, because I remember looking at that.
Shasta's right here. Lassen's right here. On that same line, we've got Lake Almanor. Right? It had a couple of fives, if I'm not mistaken.
Yeah, and it had
two different
fires all around it too,
and lots of fires, and even up into Lassen. But you follow that straight line, it leads right to Tahoe, and look what's happening in Tahoe. Look at that swarm, right in the middle of the lake, right, and also on Kings Beach in the north, and up in the Reno area, and USGS has I think in Carson City, I think that's right in that area, Green Acres. This is where what was a Green Valley, Big Valley was filmed and all that. Right up in this area is where they build their USGS homestead, or whatever they call it. Where all the geologists hang out. So it's up in here. They believe it won't quake up there, but then they found out, there was a 7 in Tahoe before. So something very, very strong. We see out of Walker, Lake Walker as well, which I think is why it's probably called a Walker Lane. Texas kind of veers off to the east. Walker Lane continues going down the south, down Owens.
Yeah, it's after one of the explorers that was with Owens. Yeah, because Owens Valley's named after one of them too. So there's one of the explorers that was named Walker. So that's where they got the Walker, and I think it was his guide or assistant. I think was Owens. So that's how Owens Valley got its name.
And Muir was one of the other guys too that did that.
Yeah, he was there in 1872 in Yosemite when it happened, I think.
Yeah.
When the quake happened.
So I mean, and the tallest mountain in the continental U.S. is Whitney, and it's pretty damn far up there.
Because Fort Tejon is where they took all the indigenous people from the Owens Valley to, and that's why there's a reservation there, right?
Reservation, yeah, okay. Tehachapi, yeah. Tejon is right here, Fraser Park area. There's a ranch up there, Ranch Tejon. I've driven that several times. It's not fun, especially with all the big rigs. And then there's a hell of a grade coming from up at the top down into Wheeler Ridge. That's pretty serious drop, from the mountains. So it's in a big valley on that end, the Tehachapi Hills and stuff. And I have neighbors and friends that are from this area that moved right next to me, 2 different sets. So it's kind of wild. And crazy. But even you can see Ridgecrest, it's still banging because of, Ridgecrest is not something like it just happened in 2019. No. It gets 5s, 5.6s and stuff like that. Just hasn't gotten a 7.1 before that they know of.
Yeah, because it had a swarm of 5s back in 95, right before the big Colima 8.1 quake happened. So the swarm was in June, and I think Colima was like the next month or whatever. Yeah, July 95.
So back to the Nevada thing. Right here, you see what happened with the earthquakes happened in the last month. Right here and right here. Odd that they're on 3 different sectors, maybe unrelated, but why? Bing, bing, bing. How does that happen just tectonically? How does that happen? Why? What pressure? At what angle is the pressure being pushed? Now, it seems like it's being pushed north of Vegas, coming out of the Wasatch and coming down the backside of the basin and range down the Texas limit there. But could the bend in the Garlock that you see right here, this right-hand kind of down-sloping bend, could that be because there's pressure pushing right up against the mountains here, and all this is being pushed out this way, all this is being pushed up that way?
Well, I think it's coming up at Walker Lane and then spreading to each side.
Right.
That's what I think.
That's what I do too. The movement in Ridgecrest was to the left of the fault, went south. To the right of the fault, went north.
Since we had the Peru quake down there, whatever it was, I can't remember now. What was it? 7?
And you can see the last 30 days. The last 30 days, you see that from the Imperial Fault moving on to the San Andreas Fault, not a whole lot of activity. This activity is happening on a San Jacinto Fault in conjunction with the other faults that go through here, offshoots of the San Andreas activity. And then you'll see kind of out from, the sea moving north, moving north. And then we got this other one north and another line moving north, and then this pile up here. So it almost seems, and that's why I was looking real hard at that Point of Hills, this image here. I want to see the orientation of these faults because I'm trying to ascertain it's being pushed up this way, and then you'll see one, well, it gets stopped here, so it splits over to the right. It splits over the right. It splits over the right. It splits over the right. Because the pressure is not just straight in that direction. It's kind of more of a due north direction. And if that's the case, you can see all the tension being pushed on all these different faults. And
so the Peru quake was June 30th, 7.2.
In what year?
Just whatever it is, 6 weeks ago, 7 weeks ago.
Okay. Yeah. The southern Peru, right?
Yeah, the 7.2.
Well, there's been a fair amount of them this year. What else can
So,
we?
so I think it's coming up from there, and by
Mhm.
all the stuff I've studied before, when it's like 7s or above, it takes anywhere from 5 to 8 weeks before it gets to Southern California.
Right. And that's why when the Peru quake hit in 1999, I think it was in May, we were looking real hard at what was going to happen in the north. And then when Canada popped up there by Hawaii, said, whoa. And then right off the coast of California the next day, the Gordic Escarpment popped. And we said, uh-oh. And then Ridgecrest area popped.
But there hasn't been anything super big in Mexico yet.
No, the last one was Acapulco. Yeah, and we haven't even seen a well, we did have one off the coast of Baja here. I don't remember how large that was.
And we had the swarm up by Vancouver Island.
Correct. It again, the whole thing is all one giant system. If and this is probably leads into what I was looking at today. We have this Juan de Fuca, right? Is what little bit of a plate left. If you rolled it out, like if you pulled it out from underneath the American plate, North American plate, and pulled back North America, how far does it go? According to Professor Nick, the Rocky Mountains are only 50 million years old. If I understood him correct. That's prior to Wawa. That's prior to all this other stuff being accreted. Now, part and parcel of the Sierra Nevadas and the Great Basin and Range, I think the Basin Range are 35 million years old. I think that's the last number that I've got. So how does that work? The Basin Range are 35 million years, but these mountains here, the Sierra Nevadas, are 110 to 85 million. What about the?
Well, and the super volcanoes blowing up are 35.
I don't know what you mean. Go ahead.
The 35 and under too, 35 million years and under.
Right. The Cascades. Under 35.
Oh, the super volcanoes. So Utah, Nevada.
Right.
California.
And Arizona here.
Yeah.
Arizona had was a big I found out about this after the fact, but there's a super volcano right up in here that exploded. It's not a stratovolcano, but tephra and pyroclastic flows went from here all the way over to Barstow. And Kingman, we can see the flows, the lava flows that flowed out of it, and it wasn't just one big giant one, but it was a series of vents that came up and basically welded shut whatever was going on, and that's 17 million years ago. So, wow. So
well, that 17 million, I'm glad you mentioned that, because that's the same time as the Chilcotin basalts where the big landslide was.
Where's that? Oh, up in Canada?
In BC, yeah, because I've been studying that area.
Wow.
And that whole area is all basalts that all came up 16 million years ago, because it's between the coastal range in BC and the foothills of the Rockies in Canada. And there's a whole bunch that came up there. And they, in Canada, from all the studies, they're having a big debate on what caused that. So they don't know if it was the Anaheim hotspot doing it, or and well, I say Anaheim because it's ANAHIM. to differentiate from the other one.
Uh-huh.
But anyway, so they debate why the Chilcotin basalts are there. And the Chilcotin River comes right down through the center of it. So where the landslide was, that's basically the center of the basalts that are on that plateau that's between the coastal mountain range of BC and the foothills of the Rockies. So it's pretty interesting. So I was looking at all the dates they have for that. And then when Nick was doing his show the other day, I was in there on YouTube, and there's a bunch of other people that were from up there. And of course, he was trying to figure out what was going on, why all these magma breakthroughs were causing all this stuff and what it was that was doing it. Well, then I'd been reading about the Chilcotin and all that, and there's other people in there from BC. And I said, well, this one busted through 16 million years ago, so what did that? So that just got everybody all going even more, because there's all these other things now you have to factor in. So there was something that was causing it to do that, whether it was the hot spot or, well, something else that was causing all that to come up. Because they basically said it came out like fissure eruptions, except there are hills or mountains there that they know that it came up through. So there's a big debate on if it was like a bunch of just like volcanoes, or was it fissure eruptions, or what caused all this 16 million years ago up there. So I don't know. It's interesting with all the different dates on stuff. Like Nick never went up that far because he's sticking in Washington. But if he went
he
across,
can get easily overwhelmed. And he's got a lot on his plate. So I appreciate, what he's doing.
And how it's kind of angled is northwest to southeast too, the Chilcotin. So it's pretty interesting.
I'm trying to find out how old the media crater here is in Arizona. This page, media, you can do that. Media crater AZ. All right. Impact crater. Well, there's a city called Media Crater. I'm gonna try that. There's Meteor City. When did that thing hit? Not finding. I was breathing in. I was not whistling. I'm trying to find out what time that thing hit, the estimated date. I don't know, I guess meteor, right? Crater AZ. There we go. All right. So Media Crater National, like $600. What the hell? Age is 50,000 years. Okay. So that's out of our 17,000 window. But 50,000 years, when that thing hit, that's when the start of the stuff that Professor Nick's going to talk about happened. Was there only one crater? I wonder. Flare in progress, he says. All righty. We'll check it out. Oh, yeah. An M1. That's what it'll end up being, M1. So we've already, today, we were having an looks like an M4, and then we had a M432, then an X1, and then we had an M1, and then a M5.1, and then now we just had an M1. Crazy times.
Yeah, so Wawa Springs in Utah was 30 million years ago.
Right. And when Nick's talking about his stuff tomorrow, pay attention to the dates. If they think this happened at 50 and that happened at 30, and then we got a couple of these others happening around 17, we need to know what's going on in those time periods, because they could show evidence of why these events were happening. I mean, Nick's going to start, I think, at 52, and he's going to go down to present. I don't know how long he's going to go, but he's specifically dealing, the section that he's dealing with is just the volcanoes up there in the Pacific Cascades, because he doesn't know anything about them, so he's researching them.
Yeah.
But a lot was going on from 50 million years onward. Even 60, 66, I don't know if it happened at 66. It could have happened at 52 or 60. I don't know. I'm not holding them to a 66 date. But
La Garita caldera in Colorado was 26.3 million years ago. So see, you're getting in this 30 million range again with all these. So it's pretty interesting.
Right.
When they were all blowing up. So what was going on at 30 million years ago? See, there's all these different things where stuff was busting through. Which
that's what I'm trying to get at. 30 million years. Wawa popped, and Wawa was way bigger than Yellowstone. I mean, and then we have another one. Peach Springs is the one that's by me. 17,000 years or 17 million years ago. Yeah.
Well, see, there's another 17, 16
right
time frame again.
Yeah,
because I think they're not spreading it out far enough to find out what's causing like all these different things at the same time. Is it a hotspot track? Is it something else? Like, why is it doing it at these different times?
Well, even Valles, right? Prior to Valles volcano, there was another volcano there. Just barely over 2 million years. And then it blew itself up. Then Valles came in and blew itself up. And then a couple of other small ones then did that. But that's in New Mexico.
Yeah.
So, and you're talking really recent. And then there was a volcano that erupted right around the turn of the millennia, 1,000 years ago, right in along the Colorado River north of Meade. So in the Grand Canyon. So that happened, and I don't know what happened when San Francisco Peaks blew up.
That was
1.3 million years ago.
Yeah, it was not that long ago.
It blew up 1.3 million years ago and lasted until 100,000 years ago.
Yeah.
That's pretty insane. That's recent, but look how far inland that is. Here I am. Here's Flagstaff. Here's San Francisco Peaks, right? This volcanic range right here. What was it? 1.3. That's the same kind of time period that Valles was going off. Oh, where am I going? Here. Oh, where am I going? What happened to my map? Okay, right here. Right? All of this was erupting under 2 million years ago. Same as over here in look for the Millennium Falcon. Right here. This area. So we have this area 2 million years ago, this area 2 million years ago. Erupting.
Yeah. It says Long Valley last eruption was 760,000 years ago.
Right.
So it's more recent than the other ones.
Right. So what happened? Did you get bopped off? Yeah. He was there. Oh, wait a minute.
It's weird.
I don't know. You got bumped off, buddy.
Yeah, he was there and then he was gone.
He was talking, and then all of a sudden it said Canuck joint. Wait, what? He's talking.
It's doing the thing it did before. It's disconnecting.
Yeah, and I'm stressing this point over and over and over because I want to say that when Nick's talking about the Pacific Northwest, he's talking, 50 million years ago. This stuff is recent down here. I mean, recent, 2 million, 2.5 million years ago, 17 million years ago, 30 million years ago.
That's a lot
Right.
more recent than 50 or
And 50.
80 million years.
Or even 35 up here where the Cascades begin. So let's say it landed at 50 million years ago. Rangelia landed in between 80 and 100. Part of it's here and part of it's way the hell up here in the Rangel. So there are things that when it comes to plate tectonics that I think there's a lot of suppositions out there that they're taken for granted because they think they know the age of the rocks. And maybe the rocks, kind of like an ice shelf, ice moves the rocks more. I don't know. But what I'm finding out that their ages don't jive. In all of our deep studies that we've been doing, the ages aren't driving. It's like, let me see if I can share this little thing here. And I'll probably, I don't know how many hours, what time we got in there. We're an hour 46. Yeah, we're going to end with this. Share this, share screen, window, boom, here you go. And bring it up. Now, because I'm bringing this up only because of Professor Nick. All right. This is the Wanda Fuca. These are the arrows, the direction of the plate, 59, 69, 90. These are the further away you get from land, the faster the Pacific plate's moving in the same direction. You have a rift, which is part of the Wanda Fuca. Then you got a strike slip, which is the Blanco. Then you got another rift, which is kind of a muddier rift. And the Wanda Fuca moving in a northeast direction. That's the direction of the Wanda Fuca, everybody. It's northeast at 26 millimeters a year. Look at what happens when you put it in play. North America moving to the right, that moving up, and that moving out. Ready? Start to see it right now. Where's it go? It disappears. But Wanda Fuca is going in that direction as North America is floating over it, going over it. That's what's happening. This hasn't moved, but at the same time, this is moving north faster. Almost 3 times faster is the Pacific moving north than North America moving across Wanda Fuca. If they're correct in their suppositions, there should be a big giant hole out here. But how come there's no hole out here? If indeed the Pacific plate out towards Hawaii or way off the coast, 1,000 miles out, is moving at 90 millimeters a year, and then just outside of Wanda Fuca, it's moving 69. Then closer to the shore, it's moving 59 millimeters a year. If you did the math on all of these things, it's kind of a trip. It doesn't jive. It doesn't jive in my mind. And we don't know how fast these spreading ridges or these rifts are growing, so that can speed things up, counter up. But it's believed through GPS that the Wanda Fuca is moving at a northeast direction at 26 millimeters a year, which is roughly, what is it? I got here my notes. 1 inch a year. All right, 1.024. And if I did the 1.024 for 1,000 years, right, it would give you a number, and you would see how much it moved. And it's Juan de Fuca is not here 20 million years from now. It doesn't exist. This is the last stages, and this part right here, where the Blanco fracture zone is pretty close to shore, but it's not. What happens when this gets subducted? Does it change direction? Does the plate break? Does it rip? Does it tear? What happens? And Professor Nick, he's going to be talking about some of that in his his view as North America moves in a southwest view, which that's the direction it's moving. Juan de Fuca is moving north, and the Pacific plate's moving that way too. So this kind of shows you as the shoreline is here.
Yeah, because he's trying to figure out what caused the magma breakthroughs and all the different
Correct.
spots. That's basically what he's trying to do.
Yeah, and he's laying a foundation. Now, this is all what's happening on the shore, and he's going to be talking about the chalice show on stream. This area right up here. Here's the Idaho batholith right here, and all these holes that it created a lot of magma, the Columbia embayment and all that stuff. The chocolate whatever, that's 3 miles thick. That happened out here. I think that happened sometime around the chalice magmas, which are all through here. And what there's an age progression of these chalice magmas. I think that's really interesting as well. And how he's looked at them going, hey, wait a minute. There are dates here that don't correspond, right? But he'll also talk about this one here.
And that's why he likes the ghost volcanoes too, right?
Yeah.
Or what he's calling the ghost volcanoes, because he's trying to figure out how they did what they did and why and everything else. Right?
And why they die out. This 706 line, that's believed to be at the time of Silesia banging North America. That's the coast. All the exotic terrains came in they were outside, passive and active margins, all outside. The passive is right here. Everything out there.
Because I think what he's going to end up, he's going to get into what he doesn't want to do, but that's naming all these oceanic plates that subducted.
Right.
Which he mentioned that before.
The resurrection, the Kula. Yeah.
That's what, because
too,
what I think is happening, it's actually all the triple junctions are being subducted, and that's what's the breaks are in the plate. That's what I think it is. At all these different times, especially the ones he's focusing on from whatever 40, like say between 53 and 40 million years ago. That's probably what he's going to find. I don't know what Tepper's going to say, because I haven't read Tepper's newest paper yet, but I know he's been doing the whole thing also up into BC too, so hard to tell what he's going to say, because I haven't read the paper, so I don't know yet. I haven't had time. Because there's probably all these crazy, because triple junction is 3 plates meeting. Mm-hmm. Well, the more plates you have, which they're finding from the tomography, because that's what the subducted slabs are down in there. So then they have to give each one a name And then they say, well, this is an oceanic plate between this, and this, and it's subducted here and went down under, and that's why it's there now. So then what they're doing is they're finding there's more oceanic plates than what they thought, and each one is subducting. So you have to, and it's always like there's always water between the islands, right?
Yeah.
Water between the islands, and so they have to give that plate a name, and it subducted into a trench or went under or whatever it did. But
and some of the rocks that came up out of a subducted trench, and that's why they're metamorphized. They changed.
Yeah.
And that's why they said, okay, well, there was a trench out here at some time. And there's another problem I have a lot with Canuck with what they're been putting out, and these scientists, and that is, well, there was a time period probably too recent for them, but there was an inland sea from Texas all the way up into Canada.
Yeah, which would have been back way farther.
No, I mean it almost, if I'm not mistaken, 50 million. Was that it? I could be wrong. Don't quote me on that. I'll try to find you real quick here, because I went what? Oh, what are you talking about?
Was it 50 to 80 million years ago when that happened? The inland sea.
Yeah. There was 140 when the moved. And he's talking about the Templar. Yeah, I mean, I've got all the notes that he's got that he posts. I do that.
Wasn't the inland sea still there when Chicxulub hit? I think, which was 68.
Well, Chicxulub is 66, right?
Yeah, 66 or 68, whatever it is.
Right. Yeah, and I've got some of it, but I think it might have been another folder here. Hold on. No, not that folder. Anyway, I find it really, really interesting of the inland sea here 92 million years ago. All right. And look how big this 92, right? Igneous province. You're damn right. There was an igneous province. It's called let me share it with you. Let me share this screen window right here. All right. This is at 92. All right. That's at 92 million years ago. How long do you think that it took for that thing to fill up or to dry out?
Quite a while.
Yeah, you'd think, right? So even if it gets down to 50, it just sank or it just rose or whatever it did. This side down here where his fingers are, that's the creation of the Sierra Nevadas. This is a part of up in Portland right in here, and Washington up in here. But there's an inland sea that goes up there as well, and this is prior to the Colorado River, prior to the Basin and Range, prior to Wawa, prior to Yellowstone hotspot, prior to any one of these. And yet taking this and adding it to the Craziacean, it's almost as though the Craziacean created this mess right here. But what did it do? How did all that be created? So some of the ideas that are out there, these suppositions and theories and hypotheses, they don't jive. And yet here we are trying to make sense of them, going, okay, but there are other ones in this that, I could I can show you 150. Here's 100 million years. Oops, it won't show it, so I'll have to do it again. This is somebody else's. 100 million years. So 8 million years prior to the last one. You can see it started at the top, went all the way down, and worked its way through. But didn't that look like an igneous province out there? You know? Is that what slammed North America at, Rangelia? Where's Rangelia in this? Is this it right here? This big old glob? The super whale or super terrain or the, and then you have the, over here, you got the, the mid-Atlantic out here.
Well, and Gaiachan and Mescalera would have ran into North America first, but I forget what the date is for that. Like 109 or 120. I can't remember what it is. Can't find it now.
Well, the craziest.
That's the big arrow-shaped archipelago that's under the East Coast now.
Right. And the idea of a Pangea type thing. This is what Pangea 180 million years ago looked like. So I'm going way back in time. North America being up here, India here, Australia down here, right? South America here. This moved up and out, right? So this is Pangea basically. And there are a lot of other provinces around the world, but this is 180 million years ago. The theory, it's all theoretical, but we have to try to make sense of it. And I don't know that going before Pangea here and saying, well, there was 8 different supercontinents like what we talk about. I don't know if that's productive, but it is productive to see how everything fit together at one time and then kind of exploded from there. And we've yet to even talk about asteroids and, comets hitting the Earth and doing a number. And if our Earth was smaller or if it's larger, if it's growing, getting greater circumference. There are so many different things out there to really try to explain this. The Earth could have been real small and then grew. I don't know how that happened. I don't know how it happens, but all right.
But what's interesting is the intermountain seismic zone makes the same arrow shape as Gaiachan and Mescalera. So that's pretty interesting.
All right. Well, we'll have to bring that in on Saturday.
Yeah.
Yes.
Yeah.
It's 2 hours already. Yeah. Clem, do you want to ask any questions, or do you want to add anything, or is something like piqued your interest, or respond to what's been talked about or whatever?
I think that would be probably better for a Saturday rabbit hole.
Yeah.
All right. What about you, Canuck?
Yeah. I can't think anything else tonight because
I know World War III is happening, but we'll talk about this after we get off of this blog, or what do you call it, vlog or podcast?
Yeah, I don't see any. I'm not getting any updates on World War III tonight, so it must be delayed till
that's
tomorrow.
Good. QuakeCat says no trench, and that's why Cascadia is a different type of subduction system. Western coast is way different from the eastern. Absolutely. While who say faults don't stop at borders? And they don't.
But the problem is with the triple junction, you have 3 ridges. That's the only problem.
The Appalachian formed 260 million years ago, though the oldest rocks exposed to the surface are 500 million years old. Yeah.
Because it makes the Klingon symbol shape, the triple junctions.
Well, you got to show us on that. And, hopefully, I got to make some money. I've been pouring every dollar I have into this. But it's all good, it's fun. And I'm having a lot, I'm learning a lot, and I'm having a good time with all y'all. I don't know where everybody was last night. Tim and I had a good time, just us. And I know Susan was, simply Susan was watching, and it's all good. We love her. I don't have anything else to add for tonight. Hey, thank you so much, guys, for being here. I appreciate both of you.
Yeah, thank you.
Thank you, Kat. Thank you, Eden, Vampy, Simply Sue, Flutter Girl, Beth, Hugo, and Timmy Boy, of course, Susan, sister. Oh, and 42 made it too. Can't complain. Love y'all. Thank you so much. Thank you for your tips, your subscriptions. They do help. I think I have yet to cover my nut in this whole thing for the longest time. They take $5, and every $5 donated here with your subscription. And now there's $6, by the way. 6 something. I think it just started July 11th. And if you've got free Amazon, that's great too. But they take half of that. So if I get 100 subs, I only have 50. So 100 subs is not a lot. And tell people about what's going on in rabbit holes. And if you tell more people want to see the rabbit holes, then we'll make more rabbit holes. But right now we're doing 2 days a week, and I'm having a great time. This one went real long.
Yeah.
I don't know if we had any kind of order, but we had a plan. I don't know what happened to it.
It just got extended because we added more stuff.
Yeah.
That's what usually happens.
This ding-a-ling is out. Oh, love y'all. Have fun. Thanks for everything. And we'll talk to you in the morning sometime.
All right.
All
Good
right,
night, everybody.
Good night, bud.